Tells you where.
Okay, let's see the homework. Let's go.
Hello.
Hello, what?
Why? Just. I spoil my brother.
Someone want to spot me like 3:57, but I'm leaving until.
My brother doesn't eat school lunch, so.
I did, but.
Okay, let's do this quickly because then I want to pass out the calculators after too.
Oh, I don't. You know what? Justin, why are you calling me?
Okay, you're gonna have to draw graphs on the test, I already told you, and some of the other problems are, they're gonna give you the graph and they're gonna, which of the following is the equation, so you're gonna have to end up graphing it anyway. Okay, so A, y equal 2 cosine 3 x plus pi over 6 plus 1. So the first thing you wanna do is graph this. Graph that first, don't worry about anything else. And then you just shifted pi over 6 to the left and 1 up. You guys can handle that, right? Although I don't know. So 1, 2, 3, 4. This is 2 pi, this is 1, this is negative 1. So cosine, the graph looks like this, right? Okay, now what does that do to the graph? It multiplies the y's by 2, so this would be 2 and negative 2. This multiplies the x's by the reciprocal of that number, which is 1/3, so this is like 2 pi over 3, which means this is like the one I did yesterday. Pi over 3, this is pi over 6, and this is pi over 2. So each hash mark on the x-axis is going to be pi over 6. Okay, so all you have to do now, shift everything, pi over 6 to the left, and 1 up. So how should we do this? Like, okay, so every point shifted pi over 6 to the left and 1 up. So here's this point. Pi over 6 to the left, 1 up. This point. Pi over 6 to the left, 1 up. This point. Pi over 6 to the left, 1 up. This point. Pi over 6 to the left, 1 up. This point. Pi over 6 to the left, 1 up. Pi over 6 to the left, 1 up. And then connect the dots. And then once you get that, just copy and paste. Do I need to do the pasting? No need, no, you guys can copy and paste.
Of course.
Okay, and then B. B, what do we got? Y equal negative 3 sine pi over 4 x minus 2 minus 1. So this is what you want to start with. Negative 3 sine pi over 4x. If you can graph that, then all you gotta do is shift the 2 to the right and 1 down. Right? So how do we graph this? So 1, 2, 3, 4. 1, negative 1. Now sine looks like this, but this is negative, so it's gonna get reflected over the x-axis, so it's gonna be like that, correct?
Yep.
What does that do to the graph? That multiplies the y's by 3, so this is 3 and negative 3. This multiplies the x-coordinates by the reciprocal of that number, which is 4 over pi. So if you this looks like the one we did yesterday too. You cancel out the pi's, that's 8 then. So this is 8, which makes this 4, which makes that 2, which makes that 6. So now it's easy to shift 2 left and right, because that's just one hash mark, right? So all you gotta do now, shift it 2 to the right and 1 down. So everything goes 2 to the right and 1 down. So that means So take your key points. Here's the key point there. Shift it 2 to the right and 1 down. Okay, this one here. 2 to the right, 1 down. This point, 2 to the right, 1 down. This point, 2 to the right, 1 down. This point, 2 to the right, 1 down. And then connect the dots. And like I said, I don't care if you copy it on this side or if you copy it on that side. I don't care. Copy and paste. Okay, C. Y equals 3 tangent pi over 8 x plus 2. So this is what you want to graph. You just want to graph this and then shift everything 2 to the left. That's all you got to do. Okay, so first you graph the tangent graph. Now I don't care which 2 consecutive asymptotes You guys want to remember, I remember these two, negative pi over 2 and pi over 2, and tangent goes upward. Now, what does this 3 do to the graph? It multiplies the y coordinates by 3. Now, normally, you have pi over 4 comma 1, right?
Mhm.
So, instead of 1, it's 3 now, and negative 3. That really doesn't affect the graph that much. And then, what does this do? This will multiply the x coordinates by the reciprocal of that number, which is 8 over pi. So, if you multiply this by 8 over pi, the pi's cancel out, and what is 8 over 2?
4.
4. So, this would be 4, and this one would be negative 4. See, and then it's easy to shift 2, right? Because 2 is just like half of that, right? So, all you gotta do now is shift everything 2 to the left, which is 1 hash mark, so like that. So, everything goes 2 to the left. So, this asymptote goes 2 to the left. This asymptote goes 2 to the left. This x-intercept goes 2 to the left, and then you know how tangent goes, it goes like this. Yeah. And then copy and paste. Okay, D. I'm guessing it's a cotangent graph since it's like I'm going in order. Y equal negative cotangent 2x minus pi over 4. So this is what you want to graph first, negative cotangent 2x. Graph that, and then just shift everything pi over 4 to the right. Always do the shifting last, right? Okay, so cotangent. What are the consecutive asymptotes for cotangent? 0 and pi. That's the problem then, yeah? And then does cotangent go up or does it come down? It comes down, but that negative sign means you reflect it over the x-axis. So instead of coming down, it's actually going to go up now because of the minus sign. And then, what does this do? It multiplies the x coordinates by...
Wait, what?
What does this do to the graph? It multiplies the x's by the reciprocal of that number, 1/2. So then, that's pi over 2, which means that's pi over 4. So it's easy to shift pi over 4 to the right because it's a hash mark. So everything just gets shifted pi over 4 to the right. So this asymptote goes here now, this asymptote goes here now, and then this x-intercept is there now, and then now it just yeah, like that. See how easy graphing is? Are you guys gonna remember all of this when you take pre-calc? Of course. I hope so. Okay, E. E, what do we got? We got y equal 4, secant. Secant, pi over 6, x minus 3. Okay, so this is what we want to graph. Okay, so we want to graph this, and then you just simply shift it 3 to the right. That's all you gotta do. Okay, how do I graph this? What do I do? What do we start with? You start with the cosine graph, right? So, because secant is the reciprocal of cosine. 1, 2, 3, 4. 1, -1. So cosine looks like this, right? That's cosine. So how do you graph secant then? You hump up and you hump down. So whenever the graph touches the x-axis, you're going to have a vertical asymptote there. And since the graph is humping down, you hump up, and then since it's humping up, you hump down, and then you hump up. So that's the graph of secant right there. What does that do to the graph? It multiplies the y's by 4, so this just becomes 4 and -4. What does that do? That multiplies the x's by the reciprocal of that number. 6 over pi. So if I multiply that by 6 over pi, the pi's cancel out and you get 12. So if that's 12, that means this is 6, that's 3, and that's 9. See, that's why it's easy to shift 3 to the right, yeah? So now, just take this graph and shift everything 3 to the right. So just shift everything 1 hash mark to the right. So these two asymptotes go here and here now. I need another hash mark over here. Because that would be 15. Yeah. So everything gets shifted over. So where? Oh, I can hardly see the blue. So right here. So then this goes hump up, hump down, and then hump up. And then copy and paste is needed.
Wait, how do you find the asymptotes again?
When the cosine graph touches the x-axis.
Oh, okay.
Because when the y coordinate is 0, what's the reciprocal of 0? Undefined, right? That's when you have a vertical asymptote. F, y equal 3 cosecant 1/2 x plus pi over 2. So this is what you want to graph. You want to graph this. Graph that. Just worry about that first, and then just shift it everything pi over 2 to the left. What, did you win?
No, I'm writing.
1, 2, 3, 4. 1, -1. Okay, cosecant is the reciprocal of sine. So you graph the sine graph. Okay, when do you have vertical asymptotes? When the y coordinate is 0. So right there, there, and there, you're going to get vertical asymptotes because the reciprocal of 0 is undefined. And then you just hump up, hump down. Okay, so that's the graph of cosecant x. Now what? What does this 3 do to the graph? Just like all the previous 5, it multiplies the y coordinates by 3. So, what does this do? It multiplies the x coordinates by the reciprocal of that number. What's the reciprocal of 1/2? 2. So this would be, what is 2 pi times 2?
What?
4 pi. So that means this would be 2 pi, that means that would be pi, and that would be 3 pi. So you gotta shift everything pi over 2 to the left. So pi over 2 would be half of that, so maybe you might wanna do that then, right? So there. Just shift everything pi over 2 to the left. Because, okay, on the final exam, they're gonna give you like a grid, you know, graph paper, and then it's up to you to put the scaling in and things like that. So shift just whatever you see here, just shift everything pi over 2 to the left. So here. So this asymptote is here now. This asymptote is there now. This asymptote goes there now. Okay? And then halfway in between, that's when you're gonna have whang. And then same thing here. Halfway in between here, you're gonna be over there. So, and there you go. That's one period, and then copy and paste. Actually, I'm trying to think of the final exam now. You guys might get lucky. I think on the final exam, you only have to graph 1 period. So you don't even have to copy and paste.
So one period has the up and down.
Well, 1 period means that's where it's gonna, like if you only graph this, that's not 1 period because that's, see, this is not the same thing as that, right?
Oh.
See, like when you have a up and a down, then the next one will be up and a down, right? When it starts repeating itself. Okay, there you go. So make sure you can graph all 6 trig functions nowadays. Okay, now what is tonight's homework? There's only 2 more before we get to the practice test. So how do we go back here? No? Okay, tonight's homework is review worksheet 3. Why isn't it coming up? There you go. Identities.
Yay.
Did you guys forget all your identities, or are they still in there somewhere?
Come on.
Now, there's going to be a section of the test. See how the beginning part? So, if you don't draw your triangles correctly, you might be in for a heap of trouble here. You know what I mean?
Oh,
So you gotta, the initial part, if you don't draw the triangles correctly, it might be very painful. So the test looks kind of just like that. Okay, you know that I can't even see that. You have to enlarge. Dude, why did this go? Ah! Okay, there. And then you can see right there, it'll test you on all the identities now. So if you want to, when you do tonight's homework, maybe a good idea would be to get out that identity sheet, which is on the website, right, on the top left somewhere, so that you can start re-memorizing them again. And then you go to pre-calculus, you gotta memorize them again, you go to calculus. That's why. Why not just learn it well the first time, then you don't have to keep memorizing. Just like your name, do you have to keep memorizing your name?
this is in the other video.
Like you need flashcards for your name.
No.
Okay, there you go. Okay, so the first thing you want to do is make sure you draw, you know what, why don't we just draw the triangles together now? But then you got to do it correctly on the test now. So what does it say? It says tangent alpha is 3/4 and it's between 0 and pi over 2. What quadrant is that in? That's quadrant 1. So draw it in the first quadrant like that. Here's alpha. Now it says tangent alpha is 3/4. Here, all right here. Tangent alpha is 3/4. So what is tangent? Opposite over adjacent, and then you use the Pythagorean theorem. Do I need to put any minus signs on any of these? No, because in the first quadrant, everything is positive, right? Now the other one, what quadrant is that? Beta is between 3 pi over 2 and 2 pi. What quadrant is that?
4.
That's in the fourth quadrant. So draw your reference triangle in the fourth quadrant like that. So that's beta. And what does it say? Cosine beta is 5/13. Okay, so what is cosine? Adjacent over hypotenuse, and then use the Pythagorean theorem. See how you got nice Pythagorean triples there? Do I need any negative signs on any of these? Yeah, on the 12, because you're gonna go down, right and down. So positive, negative. So, if you want to get maximum points for this section on the final exam, you need to draw these triangles correctly, otherwise they can't. Because then you're going to get points off on every problem after that. Okay, so all you got to do is use identity. Okay, I'll just do a few. Okay, I'm going to do stuff that's a little bit. Compute sine of alpha plus beta. Tonight's homework is sine of alpha minus beta. I'll just do plus. Okay, so the first thing you do is you write down the identity for this. What is sine of alpha plus beta equal to? Do we remember? Sine of the first, or should I just distribute the sign? Don't you dare, that's a fatal error. Sine of the first, cosine of the second, plus or minus? So you guys don't even know. Maybe we need a speed quiz
Plus,
tomorrow.
plus.
Wait, Trig, speed quiz tomorrow.
No,
No.
Why not? It boosts your grade. Can lower it too. You gotta know this for the fun. What are you gonna do? Just memorize right before you go into the test.
Yeah.
I'll do a
That's
speed
not the
quiz
answer I want.
next week.
Plus or minus?
Plus.
Plus.
Cosine and sine.
Cosine of the first, sine of the second. So I can tell you right now, this is the biggest problem for this class. We don't know our identities. And if you guys are going on to pre-calculus next year, you better know these. It's not like you just forget them over the summer. Is that what you're planning to do?
No.
Forget over the summer, Mr. Park, I forgot it from the first one. And then all you have to do now is plug in the values. So if I remember correctly, on the final exam, I think each of these is like 5 points each here. So if you don't have the correct identity here, it's like -5 already. Maybe if you just got the sign wrong, maybe -4. I don't know. Okay, so now all you have to do is look at the triangles you just drew here. Okay, what is sine alpha? Here's alpha. What is sine? Opposite over hypotenuse. Just gotta know. Sokatoa for that. Cosine beta. Here's beta. What is cosine beta? adjacent over hypotenuse. That's why you have to have those triangles correct. Cosine of alpha, here's alpha, what is cosine? Adjacent over hypotenuse. 4/5. And what is sine of beta? Sine is what? Opposite over hypotenuse. -12/13. And then, of course, if this problem was worth 5 points, you write that down, you get 4 out of 5. The last point is, can you compute this number? 15/65 minus 48/65, and your final answer is? Oh my goodness. We cannot even, 15 minus 48. -33/65. Okay, let's just do one more. No, you know what? Let's do 2 more. Let's do a double angle. You want to do sine? Let's do cosine. Cosine of 2, well, tonight's homework is 2 alpha. Let's do 2 beta then. Now, cosine of 2 theta, there's 3 identities. You can use any one you want. By now, everybody should have a favorite. Remember I told you my favorite? No, it's actually the first one, which is... No, if you don't remember at least one of them, you can't do this problem. Cosine squared beta minus sine squared beta. Does that even look familiar? Now some of you are thinking, isn't that 1, Mr. Park? No, that was a plus sign with you. It's minuses. Okay, now what does cosine squared mean again? It means cosine beta squared. That's what it means. Sine squared beta means sine beta squared. Okay, so now you just look at your triangles here. Here's beta. What is cosine? Adjacent over hypotenuse. And you're going to use these same triangles for like, I think there's like 7 or 8 of these now. Okay, what is sine of beta? Look at this triangle. Opposite over hypotenuse. -12/13. So you write this down, you're going to get 4 out of 5 points. Now can you compute it? 25 over 169 minus 144 over 169, and you get? No calculator, people. -119 over 169. Cancel the 1s and the 9, so you get -16. You just, if you ever did that, you just lost 1 point that you got. You can't cancel! Some of you just writing everything down. Can't cancel that. So the answer, that's your answer right there. -119 over 169. Okay, let's just do one more, a half angle. Let's do a cosine or a sine one. Which one you want to do? Okay, let's do sine of beta over 2. What are you doing tonight? Let me see. Oh, I see cosine beta over 2. So good, sine beta over 2. Okay, so the first thing you gotta do, here, let's move it on the side here. First thing you gotta do is write down the identity. Anybody? Young, impress me.
Square root of
Square root.
1 plus cosine sine
1 minus
cosine
cosine beta.
over 2
Okay, you just forgot one thing.
plus or minus.
A plus or minus. Is that important? Well, it probably could be worth at least 2 of the 5 points right there. Okay, now, how do you figure out which one to use? Now, if you don't know, oh, you knew exactly what I was talking about. Now, I forgot what I was talking about.
Which one do you need?
Oh, if you don't know which one to use, then just guess. Just guess. How do you figure out? Well, you have to know what quadrant this angle is in. Well, if you look at the original problem, didn't it say beta was between 3 pi over 2 and 2 pi, right? Because that's why we drew it in the 4th quadrant. But we don't have to know beta, we have to know where beta over 2 is. So what is beta over 2? How do I figure out where that is? How do you get from beta to beta over 2? Divide by 2. So just take this, divide everything by 2. Divide this by 2. Or times it by a half if that's easier. 3 pi over 4, and then divide that by 2. Okay, now, if you are between, here's your unit circle. If you're between 3 pi over 4 and pi, what quadrant is that? This is in the second quadrant. So this angle is in the second quadrant. Here, quadrant 2.
Sine is
So what is sine in the second quadrant?
positive.
It's positive. So you pick the positive one. And like I said, if you don't know, just guess, because then just take the -2, right? Because 98 is a darn good score.
Then what? What?
Because if you just leave the plus or minus there, I would take a 3. Because that means you don't know what you're supposed to do with it. 1 minus cosine beta over 2. Now, all you have to do now is look at the picture. What is cosine of beta? What is cosine?
Adjacent over hypotenuse.
Adjacent over a hypotenuse. 5/13. So if you write that down on your paper, you got 4 out of 5, and you want the last point, simplify that.
Isn't the
What's the fastest way to simplify it? Inside, again, people, when you have a complex fractions within fractions, multiply top and bottom by the least common denominator of all the fractions you see, which is 13. Multiply top and bottom by 13, and you're gonna get the square root of, so this 13 gotta be distributed over here. What's 13 times 1?
13,
What's 13 times 5? 13.
5.
5. And then what's 13 times 2? 26. So this is equal to the square root of 8 over 26, which can be reduced to the square root of 4 over 13. But isn't the square root of 4 2? 2 over the square root of 13. Can I leave my answer like that? Or do I have to multiply top and bottom by root 13 to get this? I already told you already. No, you can leave your answer like that. I'll accept either. But you have to simplify it to one of these though, that's the thing, to get the last point. But you know what the key part to this whole section is? You gotta write down the correct identity, because if you don't write down the correct identity, it's pretty much a fatal error. Can you imagine 10 of these problems and you get -5 every time? That's -50. That means the highest you can get is a 50. You have to memorize those identities. You cannot, like when we first learned it, you cannot get by without those identities in trigonometry. You can see it again in pre-calculus and then the 4 semesters of calculus, and if you go even past that, you gotta know it. And then when you're finally finished with math, then you purge it from your memory. Or you want to purge it every summer, every end of every semester, and then relearn it every time. It's just like you take Japanese. Don't you have to know certain basic things?
Yeah.
What do you call those things?
Kanji.
Yeah, whatever. Whatever it's called.
Your kanji.
Okay, don't answer me.
Your kanji.
I'll give you kanji. Okay, we are done. We have 25 minutes left. Hey, I got an idea. Why don't I take out my identity sheet, pull it up on my iPad, and start doing problems? Then I can start memorizing now.
Mr. Park, I have another idea.
What?
Can you give us the calculators?
Yeah, I am.
Oh, they came in.
We're still, yeah, but if I'm passing out